In this video, we're going to look at dot products. So, what is a dot product? The notation for a dot product is u, the vector u, with a big black dot, times the vector v. So, u dot v is the same as taking the two vectors and dotting them together. And it's the same as taking u1 times v1 plus u2 times v2. Okay? The dot product of the two vectors always ends up being a scalar. We'll use this to find the angle between vectors and to calculate work. So first, let's just practice finding u dot v. So if I have some examples here, u is 3, 4, and v is 5, 2. I want to find u dot v. So for this first one, you're going to take u dot v, and that's going to be u1 times v1 plus u2 times v2. So that gives me 15 plus 8. So the dot product is 23. Alright, I want you to try this one down here on your own, and you should be able to get negative 10. Okay? Now this third one has our i's and j's. So remember, you can also see I written as this, but I like to use the hats. So we have u is 2i hat minus j hat, and v equals 3i hat minus 5j hat. So you have to remember I is going to be 1, 0, and j 0, 1. Okay? So if we want to dot these two vectors, that means that u is 2, negative 1, and v is 3, negative 5. Okay, so we have u dot v dot, and we'll have u1 times v1 plus u2 times v2. So that's going to give us 6 plus 6, oops, plus 5, sorry. Can't multiply today, and that gives us 11. So the dot product itself is pretty simple. So now we can look at something a little bit different. We want to find the angle between two vectors. So to find the angle between two vectors, we'll have, if theta is the angle between two non-zero vectors u and v, then the cosine of theta is u dot v over the magnitude of u times the magnitude of v. So this can be rewritten so that theta is the inverse cosine of that same thing, u dot v all over the magnitude of u times the magnitude of v. And that's always going to give us an angle between 0 and pi, because that's where the inverse cosine is restricted to. So let's try an example. I want to find the angle between vectors u and v. So if I want to find the angle between vector u and vector v, I want to take the inverse cosine of u dot v all over the magnitude of u times the magnitude of v. Okay? So u dot v is going to be u1 times u2. So I'll have 2, oops, this is supposed to be a positive 2. There we go. So we'll have 2 times negative 2 plus 3 times 5, and that'll give us negative 4 plus 15. And it's going to be all over the magnitude. So the magnitude of u is 2 squared plus 3 squared under the square root, so the square root of 13. Magnitude of v is square root of 29. So you can practice finding the magnitudes of each of those. And that'll give us 11 over 19.416. So therefore we have this, I was just working inside. So I have the cosine inverse of 0.567. Remember to use stored values for this. And so we're going to have theta equals 55.491 degrees. Okay? So number 2, I want you to try that one on your own. And you should be able to get an answer of 135 degrees. Right? So remember, it's u dot v over the magnitude of u times the magnitude of v. So now let's look at what are orthogonal vectors. So orthogonal vectors are vectors that are perpendicular with the exception of the 0 vector, and vectors whose dot product is 0. So u dot v is going to be 0. So let's look at this example. We want to prove that u and v are orthogonal or perpendicular. So I'm going to take u dot v, and it's going to be u1 times v1 plus u2 times v2, and that's negative 12 plus 12, which equals 0. So u and v are, in fact, orthogonal. So now let's look at how to calculate work. So how do you calculate work? Work is usually measured in foot-pounds or Newton-meters. 1 Newton-meter is called a joule, which you may be familiar with if you've done some chemistry or things like that. So work is going to be force times the vector AB, where W is work, F is force, and the force is working in the direction of the vector AB. So let's look at an example. I want to find the work done by a 10-pound force acting in the direction of 1, 2, and moving an object 3 feet from 0, 0 to 3, 0. So I know that work equals force dot AB. So I know my force is 10. I know A is 1. We're going in the direction of 1, 2. And we want this to be a unit vector. Okay. And then we want to go in the moving from 0, 0 to 3, 0. So what this is saying is you want to make sure your vector has a magnitude of 10. So the way I did this is I wanted to make sure this vector had a magnitude of 10, so I took it and made it a unit vector, and then the force was 10. So this is my force, and this is the direction of my force. This is a unit vector in the direction of 1, 2. So what this whole first part is saying is a 10-pound force in the direction of 1, 2. And then I have this other part over here, which tells me I'm moving from 0 to 3. From 0, 0 to 3, 0. Okay? So now let's work this out. So it's going to equal 10 times 1, 2, and the magnitude of this vector is square root of 1 squared plus 2 squared, so the square root of 5, dot 3, 0. Now I can multiply this 10 in and divide by the square root of 5, so I have 10 over the square root of 5, 20 over the square root of 5, dot 3, 0. So now I can take the dot product like usual. So first one times the first one. So I have 10 square root of 5 times 3 plus 20 over the square root of 5 times 0. And that's going to give me 30 over the square root of 5 which is equal to 13.416 foot-pounds. And it's in foot-pounds because we're going direction of moving the object in feet by a force that was in pounds. So this is the answer. This is the work done by the force. So I want you to take a few minutes and we can try to find the work done by a 24-pound force acting in the direction of 4, 5 and moving an object 5 feet from 0, 0 to 5, 0. It's going to be done very similar to this problem up here. And you should be able to get 74.963 foot-pounds. Okay, so make sure you take a minute and see that you can do that second problem. So now I want to find the work done by a 50-pound force acting in the direction of 2, 3, moving in an object from 5 feet from 0, 0 to a point in quadrant 1 along the line y equals x. So this seems pretty complicated, but it's not too bad. So let's look at our force. So our force is 50 pounds, and it's going in the direction of 2, 3. And we want to make sure that it has a magnitude of 50. So we're going to make this a unit vector. Alright, so this equals 100 over the square root of 13, 150 over the square root of 13. Okay, so that's just my force vector. Now I want to find my vector AB. So I know I'm going to be along the line y equals x. Okay, so this is y equals x. So I can draw myself a triangle. If y equals x, I go over x, I go up y equals x, so it's just going to be x. And I know I'm moving the object 5 feet. So I can use my Pythagorean theorem, x squared plus x squared equals 5 squared. So I have 2x squared equals 25. So x squared equals 25 over 2. So my x is 5 over the square root of 2. So now that I know my vector f, and I know that I'm moving it along here, I'm moving it to a point along this line, so my point is going to be x comma y, which I just found to be 5 square root of 2, 5 square root of 2, because x equals y. So now I can find my work. So work equals force dot my direction. So I found my force in the direction of the force, so I have 100 over square root of 13, 150 over square root of 13, dotted with my vector AB that I just found, 5 square root of 2 over square root of 2 times 5 over square root of 2. So therefore my work is the first times the second, so I have 500 over square root of 13 times square root of 2, plus second times second, so I have 150 times 5 is 750 over square root of 13 square root of 2. Then you can put this in the calculator and you'll see that you get 245.145 foot-pounds. So it takes, the amount of work done by the force is 245.145 foot-pounds. Alright? So now one last thing. If you're given the angle between F and AB, you want to use the formula, the magnitude of F dot the magnitude of AB cosine theta, where theta is the angle between F and AB. So let's look at a quick example. The angle between the 75-pound force and the vector AB is 60 degrees, where A is -1, 1 and B is 4, 3. Find the work done by F in moving an object from A to B. So we want to put AB into component form. So AB is going from A to B. So we want to put this in component form. And so the way I do that is I take b minus a, because that's my final minus my initial. So AB is 4 minus negative 1, which is 5, and 3 minus 1, which is 2. And I need the magnitude of AB. So that's going to be the square root of 29. And from here I know work is the magnitude of my force, which is 75 pounds. The magnitude of AB, which is the square root of 29. Cosine of my angle, which is 60 degrees. And you can go ahead and put that in the calculator and you get 201.944 foot-pounds. So that's going to be the work done by the force with the angle between the force and the vector AB being 60 degrees. So that is it for this lesson. So just make sure you're using the correct parts at the correct times. You want to make sure you know your magnitude, you know how to find the angle, you know which part you're using, and you know what you're looking for. So try to keep everything in units and using those stored values. And that'll be it for this lesson.